Alright, we're starting this off, Unit 18 vectors. As with all things vectors, I'm coming into this with nothing but a pen and a dream that I'm going to do well. Okay, which is always a tricky thing to do. But without further ado, let's get straight into this. So 2a minus 3b, so I've got 2 lots of 2 minus 3, minus 3 lots of 5, 4. That's going to be equal to 4 minus 6 minus 15, 12. That's going to get me minus 11, minus 18. First one is done. Diagram shows two vectors, A and B. PQ is A plus 2B. Draw PQ. Well, A goes 2 to the right. 2B is going to go like 3 right, 1 up twice, or something like that. Goes there. So that would be like A and 2B. So PQ is going to just be the straight line connecting those 2 points, that one there, PQ. You could also do it by just adding the column vectors together and figuring it out from there. Okay, cool. Alright, we need to work out A to E. I know that AB is P, AD is Q, and that D is the midpoint of AE. If D is the midpoint, that must mean this here is also Q. Important to put the arrow on as I am adding vectors, so I know what's going on. So AE is going to be 2Q positive because they're going in the direction. So that's A done. B, AC. Well, I know that since this is a parallelogram, I'm told this is a parallelogram, opposite sides are in the same direction and not equal. So I can say that DC is P. So I'm going to go AC. It's the same as going to AD and then going to DC, which is going to be Q plus P. Finally, C to E is the same as C to E. It's going to be C to D plus D to E. Since C to D is going against the arrow, it's going to be minus P plus Q. Okay. Question 4, P is the point 0,3, PQ is 2,3. Just imagine what that looks like. You've got a point here that's 0,3. I've gone 2 right and I've gone 3 up. 2 right, 3 up. That's going to be at 2,6. So Q is equal to the point 2,6. Okay. R is the point 2,4. I want to express P to R. So I've gone 2 right and 1 up, so 2, 1. PR is equal to 2, 1. Just don't overcomplicate this. To get from here to here, you go 2 right and 1 up, so it's 2, 1. Same idea here. A, B, so part A, we've gone 4 left and 4 down, so it's going to be minus 4 to get from A to B. BC is 2, 5, so I've gone 2 right of B and 5 up. Well, 2 right of minus 1 is going to be, sorry, I should write all this in. AB is equal to minus 4, 4. The point C is going to be 1, 5. X is the midpoint of AB, and O is the origin. So this is when it can be useful to kind of think about what this looks like as a diagram. I didn't need a diagram until this point, but now I think I need one, so I'm going to put one down. 3, 4 is over here. Minus 1, 0 is over here. And that's A and B. That's A, that's B. And I know that to get from A to B, I've gone 4 left and 4 down. So to get from, let's say, A to C, that's going to be 2 left and 2 down. Oh, sorry, not A to C, A to X is going to be 2 left and 2 down, should I say? Meaning that A to X, or X, sorry, is the point 1, 2. because it's 2 left of 3 and 2 down from 4. Since we're just finding origin to x, well, that's just the same as the coordinate effectively, so O to x is 1, 2. Finally, we're asked for the magnitude of AB. I'm going to do that over here. So that's just the magnitude of AB is going to be given by the square root of, you can write minus 4 squared, but since it's squared, it's always going to be positive, so you could also just write 4 squared. I'm going to put minus 4 squared in. That gets me root 32. This is divisible by 16 and 2, so it's going to be 4 root 2. Okay. Right, cool. Don't know what's going on here on the screen, but whatever, we'll deal with it. I want to find in terms of A and or B, F to E. So I know that A to B is that. So I know that opposite and equal sides are going to be the same. So this is also going to be A. And I know like B to C goes down and right, and F to E also goes down and right. So I can also say that this is B. Before anything else, I'm going to put these on. Okay. So if I want to find F to E, well, I've kind of done that accidentally then. AI F to E is just equal to B. Similarly, if I want to find C to E, well, I know that C to E is going to be C to F plus F to B, which is, F to E, obviously. My brain is not working at this early in the morning. F to E. That's going to be minus 2a because I'm going against this arrow. I'm going from C to S, so that's minus 2a plus B. Okay. Now I'm told that C to E is the same as E to X. So straight away that I know for part B that E to X is also going to be minus 2a plus B. So I know that this here, going that way, because I'm going from E to X, is minus 2a plus B. And I want to prove F to X is parallel to C to D. So I need to work out C to D, first of all. Well, C to D is going to be the same as C to F plus F to E. I don't know why I've not just gone C to E. Let's just do that instead, because I know what C to E is. C to D is going to be C to E plus E to D, which is minus 2a plus B plus A, which is just minus A plus B, or B minus A, whichever way you want to write it. Okay. Now I just need F to X. F to X is going to be F to E plus E to X, which is going to be the same as B plus or minus 2a plus B, which is going to be minus 2a plus 2b. I can factorize that 2 from here, 2 minus a plus b. So at this point what I can say is that F to X is 2 lots of C to D parallel as multiple. Something like that. Okay. Right. OPQR is a trapezium. O to R is parallel to P to Q. Thank you. Just in case you couldn't spot that. I know that O to P is P. Cool. O to R is R. P to Q is 2 lots of O to R. So that tells me straight away that PQ is going to be 2R. So I'm going to put that on there, 2R. That's the whole thing. So not just the X, but the whole way is 2R. Okay. X is the point such that P to X, X to Q is 3 to 1. So this section's 3, This section's 1, meaning the whole thing is out of 4. So that tells me that p to x is 3/4 of p to r, sorry, p to q, which is the same as doing 3/4 times 2r. You should be going more vertically with your maths here, I just don't have room. The 2 and the 4 cancel out to get 3 over 2r, don't forget to underline vectors. So that's p to x. I want to find o to x, so I know that o to x is going to be o to p plus p to x. Well, I've just found p to x without even thinking about it. So that's going to be p plus 3 over 2r. And we are done. Don't know why that says q, let's just say r. Okay, easy. Right, question 8, almost done already, which is nice. OABC is a parallelogram that instantly tells me that opposite sides are equal, so let's just write B on here, and let's write A going that way. Y is the point such that A to B is B to Y, so A to B is B, then B to Y must also be B, so you can put that on. The point X divides A to C in the ratio 2 to 1, so that tells me that A to X is going to be 2, and X to C is going to be 1. Once again, the whole thing is a third or 2/3, whichever way you're going. So I know straight away, if I want O to X, my plan is going to be going O to A, and then going from A to X. Okay, which is nice and easy. I need to first work out A to X. To work out A to X, I know that's going to be 2/3 of A to C. So I need to work out A to C. A to C is going to be minus A plus B. So at this point, like, I'm kind of started by thinking about what I want to find, how am I going to find that, until I've got something that I can do. Now I've got this, I can kind of sub into here, which is going to sub into that. It's going to kind of unravel itself, if you will. That tells me that A to X, I'll write my next one like that, A to X is going to be 2/3 of minus A plus B, which is the same as minus 2/3 of A plus 2/3 of B. Now I know that O to X is going to be, so now subbing into this one, I know what O to A is, it's just A. It's just A minus 2/3 of A plus 2/3 of B, which is going to be 1/3 of A plus 2/3 of B. Right, that's the first one done. You obviously don't need any of this working at the top, like any of these two. So if you want to get rid of those 2 lines, that's absolutely fine. Now I want to prove that OXY is a straight line. Okay, well I've already got O to X. Yeah, I need to find one of O to Y or X to Y. Okay, because I've already got this one, O to X, if I get one more and prove that they are parallel, they will share a point, and be parallel, therefore they form a straight line. Okay, now X to Y sounds hard to me to find because I have to do the whole 1/3 thing plus A plus B, or 2/3 in the opposite direction. It sounds complicated. So instead I'm just going to find O to Y. That seems a lot easier to do, and then I'm just going to show these in multiples of each other. So actually X to Y is going to be useless for me. So let's just find O to Y super quick. Okay. O to Y, well that's really easy to do because it's just obviously A plus 2B. Yeah. Well, it should be obvious now that O to X, I could factorize out a third. That's a third. A plus 2B. Well, so that means that O to X is 1/3 of O to Y, meaning parallel. Share point O. So straight line. And it really is that easy. Okay. A lot of people that I saw that really struggled with this question decided to find x to y, but then they didn't go like in the correct direction. They started trying to do like minus this plus that, and it just got very confusing. Just find O to x and O to y, and life is just a lot easier. Okay, right. Question 9. Let's have a look. OBC, OMA, and ANB are all straight lines, thank you. OBBC is 2 to 3, so this part is 2, this part is 3. Great. That tells me that the whole thing, like O to B, is 2/5. M is the midpoint of OA, that makes sense. O to A is M, so that tells me if this is the midpoint, then this is going to have to be a half A, and O to A is also going to be a half A. I'm going to put both of them on. If you just want to put A on, that's fine as well. O to B is B. So if I know that like 2/5 of OC is B, yeah, so 1/5 of OC would be a half B. So 3/5 of OC is going to be 3/2B. That instantly tells me that this length here, B to C, is 3/2B. Or you could just think, what do I multiply 2 by to get 3? It's 1.5, so this is 1.5B. Now let's actually answer the question. I've kind of just put these details on there without really looking at the question. Write M to C. So if I want M to C, I'm going to go M to O, M to C. I'm going to go paths that I know, M to O, plus O to B, plus B to C. Well, that's going to be minus a half A, because I'm going against the arrow, plus B, plus 3/2B. That is equal to minus a half A, plus 5/2B. Okay, so that's the first one done. Now I want to write N to C as a vector. I know that N to B is some multiple of A to B. Well, let's find out what A to B is. A to B is going to be minus A plus B. I'm hoping that one's obvious. So therefore, if I know that N to B is K times that, so I can just put K times minus A plus B. Well, that's going to be minus KA plus KB. So then N to C is going to be this thing, minus KA plus KB. That's taking me up to B. I now need to get from B to C, plus 3/2B. Okay, I like grouping my things together, so that's going to be minus KA plus K plus 3/2B. And I've kind of factorized out the B just from the right hand side. Okay. Right. This is when it gets interesting again. So I found N to C in part B. I've found M to C in part A. And now I'm told that MNC is a straight line. Notice how both of these are share the point C, and they are all on this thing. So actually I don't have to find any new vectors. What I am told is that because they are a straight line, that MC and NC need to be a multiple of each other. Okay, so to write that down, I'm going to say that MC is some multiple, we'll call that multiple, X of NC. Okay, that tells me that MC, which I know to be from here, minus a half A, plus 5/2B, is equal to minus KXA, plus KX plus 3 over 2x lots of b. And I'm putting the x on each term in the brackets. Okay? Now, because of how vectors work, this a and this b are going in different directions. So if I want these two sides for the left side and the right hand side to be exactly the same, I need the thing in front of the a's to be the same. So this thing here and this thing here need to be exactly the same. And I need the thing in front of the b's to be the same. So this 5 over 2 here must be the same as this thing here. So now I've got a set of simultaneous equations. Minus a half is equal to minus kx. And similarly, 5 over 2 is equal to kx plus 3 over 2x. Okay, that's equation 1, that's equation 2. I'm now going to quickly do 1 plus 2, because I noticed that if I do that, the minus kx and the positive kx will cancel each other out. That gets me, well, minus a half plus 5 over 2 is 4 over 2, which is just 2, is equal to 3 over 2x, times by 2, divide by 3, gets me x is 4 over 3. Okay. Now I know that I can sub this x into any of them. I'm going to sub it into 1. So I'm going to say minus a half is minus 4 over 3 times k. Just move the x to the front now, because it's a number. I can get rid of the minus sign very quickly, just because it's going to confuse me. And there's minus on both. Times by 3, divide by 4, k is equal to 3 over 8. That is us done. Okay. That is one way of doing this question. That's how I like to think about it. I like to set up my simultaneous equations and solve it like that. Okay. An alternative way that you can do, if you would prefer, I'm just going to delete all this and I'll show that we get the same answer. Okay, so if you want this solution, just pause, I guess, and figure it out. Right, the exact same idea, and it works because of the same reasons, but because, so I know that n to c, I just worked out to be minus ka plus k plus 3 over 2b. And I'm going to line things up. M to c is minus a half a plus 5 over 2b. Now, because once again these are parallel, that means they're multiples of each other, their coefficients must be in a similar ratio, aka I can say that this thing here divided by this thing here is the same as this thing here divided by this thing here. Okay, so I'm going to say minus k divided by minus a half is exactly the same as k plus 3 over 2 divided by 5 over 2. Okay, now effectively I'm going to keep change flip each side. That's going to get me 2k, because dividing by a half is the same as times by 2. So that gets me 2k is equal to, times the top by 2, the denominator is going to stay the same, 2k plus 3 all over 5. So that means that 10k is equal to 2k plus 3. That means that 8k is equal to 3. So k is equal to 3 over 8. So you can see that both solution gets you the same answer. Which one you choose is up to you. If you're more comfortable dealing with fractions, and you're going to commonly get fractions in fractions like this, then use this division method. It is quicker. If you're more comfortable dealing with simultaneous equations, do the method I did previously. Either way, you're going to get full marks. I personally prefer the simultaneous equation method because this actually comes from the simultaneous equation method. But, right, who cares? You just want the answer. Right, P and Q are two vectors such that P is not equal to Q. This is a really hard question. To the point that if they could ask this on exam, there's no reason they can't ask this on exam. But if they did, this would be the question that defines the year. Basically every year has a question that defines it and that people talk about for ages. Last year was that weird hexagon one. The year before was the Pythagoras theorem with the semicircles. This would be that question. Okay, right. I've got P and Q are two vectors such that P is not equal to Q. The magnitude of P plus Q is the same as the magnitude of P minus Q. Show that P and Q are perpendicular vectors. Okay. Now, first of all, as soon as I see the word perpendicular and I've got a line, I'm thinking, well, that kind of reminds me of gradient, and the gradient should be the negative reciprocal. Now, you may never have thought about the gradient of a vector, but if you imagine I've got a vector, let's just call it A, which goes x across and y up, well, then that's going to look something like that. We're going to have x across, we're going to have y up. Yeah, so effectively, the gradient of A, the gradient of our line A is just going to be y value, the number on the bottom, divided by the number on top. Okay, and that's all the gradient is. It's this number on the bottom divided by this number on the top. Okay, so effectively, I am going to try and show that these two have negative reciprocal gradients. Okay, I'm going to let P be equal to, I don't know, AB, and I'm going to let Q equal to CD. Okay, just two different letters. Now I basically need to show the gradient of P would be AB over A. The gradient of Q would be D over C. Now, since I want to show these are negative reciprocals of each other, I need to show that B over A is equal to minus C over D, or some kind of variation of this idea. Okay, that's my kind of goal, and if I can get to that, I am fine. All right, so I'm going to rub all this out, but keep that idea in mind of what we're looking for. So let's do P plus Q. That's equal to A plus C over B plus D. P minus Q is equal to A minus C over B minus D. Okay. Now, when I am finding the magnitude, so if I want to find the magnitude of P plus Q, that is going to be the same as the square root of the top squared, A plus C squared, plus B plus D squared. Similarly, the magnitude of P minus Q is going to be equal to square root of A minus C squared plus B minus D squared. Okay. Right. Now I know that these two are equal to each other because I'm told they are equal to each other. So I can say that the square root of A plus C all squared plus B plus D all squared is equal to the square root of A minus C all squared plus B minus D all squared. Once you get to this point, it is just chugging through algebra. I'm going to square both sides to get rid of the square root. A plus C squared plus B plus D squared is equal to A minus C squared plus B minus D squared. Now just expand the brackets. Looks like it'll be a pain, but because they're all kind of the same idea, you get quite quick at it. 2AC plus C squared plus B squared plus 2BD plus D squared is equal to A squared minus 2AC plus C squared minus C times minus C is positive C squared, B squared minus 2BD plus D squared. If you wanted to write it as double brackets and expand it like properly, that's fine. You should be able to expand stuff like this in your head at this point, but what can you do? Right, I notice things are going to cancel. A squared cancels, C squared cancels, B squared cancels, and D squared cancels. So effectively I'm left with 2AC plus 2BD is equal to minus 2AC minus 2BD. Let's group things together. So adding 2AC to both sides gets me 4AC. Taking 2BD from both sides gets me minus 4BD. BD. I can divide both sides by 4 at this point to get AC is equal to BD. And if you remember what I was looking for, I was trying to get like minus BD, obviously. B over A is equal to minus C over D or something like that. I might get some different variation. I'm going to divide both sides by B and both sides by C to get A over B is equal to minus D over C. So weirdly, this side is the reciprocal gradient and this side is the negative. Doesn't really matter. Gradients are negative reciprocal. Therefore, perpendicular. Okay, like I say, that is an absolutely horrible question. I don't know if there's another way of doing it. I don't think so. If you find another way of doing it, let me know. Yeah, and that ends the unit test for unit 19, or 18, sir, I say. You've got one more to go. Right, perfect. Have a good one. Bye.